Back in the summer of 2017, something happened that forever changed the way we look at the cosmos, though at the time, hardly anyone realized just how monumental it was. Astronomers scanning the skies for near-Earth objects spotted something strange, something unlike anything they had ever seen before. At first glance, it seemed like just another small body passing through the solar system, the kind of visitor we routinely discover, but this wasn't an ordinary comet or asteroid. It was an interstellar intruder, the first ever detected, and the story of this mysterious traveler would shake up the foundations of planetary science and ignite one of the most intriguing debates in modern astronomy. The object was first detected by the Pan-STARRS telescope in Hawaii, and it was given a name worthy of its enigmatic nature. Oumuamua, a Hawaiian word meaning scout, or messenger from afar. And the name couldn't have been more fitting because that's exactly what it was. A messenger from the deep unknown, from beyond the sun's gravitational domain. Just think about that for a moment. An object that likely wandered through the galaxy for millions, maybe even billions of years, finally stumbled into our solar system for the briefest of visits before vanishing forever. A traveler that had seen the cold interstellar void between stars, a place we've only imagined, passing silently through, carrying secrets of alien worlds we may never know. Initially, astronomers assumed it was a comet because that's usually the case when icy bodies visit the inner solar system. Comets heat up as they approach the sun, releasing gas and dust, creating the iconic glowing coma and tail. But here's the first twist. Oumuamua had no visible coma, no tail, no outgassing that we could detect, and that alone was odd. So maybe, then, it was an asteroid, a rocky fragment?
That was the next logical guess. But as researchers dug deeper, the asteroid theory didn't quite fit either because this thing wasn't behaving like any known asteroid. When astronomers calculated its trajectory, they found something astonishing. Oumuamua was moving at an incredible 87 kilometers per second relative to the sun, far faster than any object bound to our solar system. To put that into perspective, that's more than twice the speed needed to escape the sun's gravity at Earth's orbit. And in other words, this object wasn't part of our planetary family. It was just passing through on a hyperbolic trajectory that no orbiting body could have. And this was the smoking gun. Oumuamua came from another star system, making it the first interstellar object ever observed by humans. But the mysteries didn't stop there because after its closest approach to the sun, instead of slowing down as expected under gravity's pull, Oumuamua sped up. Its velocity actually increased slightly, as if something was giving it an extra push. Normally, with comets, that acceleration can be explained by jets of gas venting from the surface, acting like tiny thrusters, but Oumuamua had shown no such activity. No gas, no dust, nothing, which was a serious anomaly that couldn't easily be brushed aside. And then came its shape, based on its light curve, the way it reflected sunlight as it tumbled through space. Astronomers realized that Oumuamua wasn't spherical or even potato-shaped like most asteroids. It was either extremely elongated, like a cigar, or astonishingly flat, like a pancake or shard. Some estimates suggested it could be up to 10 times longer than it was wide, an aspect ratio never seen before in any natural object, and its brightness varied dramatically every 7 or 8 hours, indicating it was tumbling chaotically as it traveled. To top it off, it was unusually reflective, shiny, even hinting a metallic surface or perhaps a smooth coating of exotic frozen ices. Cue the speculation. Was it a fragment of a shattered world? A shard of frozen nitrogen from some distant Pluto-like planet? Or could it be something far stranger? Harvard astronomer Avi Loeb famously proposed that Oumuamua might be an artificial construct, possibly a light sail, a thin reflective sheet propelled by starlight, sent by an alien civilization. While most scientists considered that far-fetched, they couldn't fully rule it out because, after all, Oumuamua defied every neat category we had. Its speed, its shape, its acceleration, it was like nothing else in our catalogs, and with no way to chase it, we could only watch as it slipped beyond the reach of our instruments, vanishing into the darkness forever. If you trace its trajectory backward, Oumuamua seemed to come roughly from the direction of the star Vega in the constellation Lyra, A poetic coincidence, since Vega was once the North Star and will be again thousands of years from now. Did it originate there? Probably not. Its journey was likely so long that any stellar birthplace has since moved, but the thought added a layer of cosmic romance to the story. In the end, Oumuamua passed within about 24 million kilometers of Earth, only about 50 times the distance to the Moon, before heading back into the interstellar void, never to return. For 2 years, it remained the only known interstellar visitor, and then, in late 2019, we found another, 2I/Borisov. This one was discovered by an amateur astronomer, and unlike Oumuamua, it behaved exactly like a textbook comet, complete with a coma and tail. Fascinating, yes, but not nearly as mind-bending as its predecessor. Borisov proved that interstellar objects do enter our solar system, but Oumuamua remained the true enigma. Fast forward to now, 2025, and we've been given another gift from the stars. 3I/Atlas. Spotted on July 1st by the Atlas survey, it's still way out beyond Jupiter, about 4.5 astronomical units from the Sun. And when I say this thing is big, I mean enormous. Its coma stretches nearly 20 kilometers, and its nucleus might be 11 kilometers across, making it 10 times bigger than Oumuamua and 5 times larger than Borisov. But the size isn't the only astonishing thing, because its composition, age, and origin could answer questions we've been asking since 2017. Atlas seems to come from the thick disk of our galaxy, a region filled with ancient stars and material that predates much of the Milky Way's spiral structure. And that means this object could be older than Earth itself, perhaps 7 billion years old. Imagine that, a piece of cosmic history older than our entire planet, carrying the chemical fingerprints of an alien solar system formed before ours even existed. And its trajectory? Unlike Oumuamua's quick hit and run, Atlas is cruising in from the side, giving us a much longer observational window and several planetary flybys. It will pass within 28 million kilometers of Mars, 97 million kilometers of Venus, and 53 million kilometers of Jupiter. Earth, unfortunately, won't get front row seats. We'll be tucked behind the Sun during its closest approach, but that won't stop astronomers from turning every available telescope toward it. There's even talk of redirecting existing spacecraft around Mars or Jupiter to intercept Atlas. Is it feasible? That's still uncertain, but the very fact that such conversations are happening shows how significant this discovery is, because if we can get a close-up view, we might finally learn whether interstellar objects like Oumuamua and Atlas are just random shards of ice and rock, or whether they hold secrets we can barely imagine. Why does all of this matter? Because these visitors are not just cosmic curiosities. They're time capsules carrying the chemistry of alien worlds, the building blocks of planets, and perhaps even clues to the origin of life. Every interstellar object we encounter is a messenger from the deep galaxy, drifting for eons before brushing past our sun. Oumuamua showed us how strange and unexpected such objects can be. Borisov reminded us that interstellar comets exist. And Atlas? Atlas could be the key to understanding whether these wanderers are common, what they're made of, and what stories they tell about the birth and death of solar systems across the cosmos. We are on the brink of another great moment in discovery, and these objects, silent travelers between stars, remind us that the universe is vast, unpredictable, and full of wonders we have yet to comprehend. And as Atlas glides closer, the question hangs in the air. What secrets does it carry from the far reaches of our galaxy? Whatever the answer, one thing is certain. The most astonishing surprises still await us out there in the dark between the stars. But the story doesn't stop with Oumuamua, Borisov, and Atlas. These interstellar visitors have opened up an entirely new field of research, interstellar object science, a field that barely existed a decade ago. Before 2017, most astronomers assumed that objects from other star systems were out there, drifting between the stars, but the chances of one entering our solar system and being detected seemed incredibly small. Our telescopes weren't powerful enough, and the sky is vast beyond comprehension. Yet here we are, with not one, not two, but 3 confirmed interstellar visitors in less than a decade. And that raises a big question. How common are these cosmic wanderers? If we found 3 in just 8 years, that suggests there could be trillions roaming the galaxy. Think about it. Every time a planetary system forms, countless fragments of rock and ice are ejected into interstellar space, forever drifting through the void. Over billions of years, these fragments could outnumber the stars themselves. And each one is like a message in a bottle. Except the ocean is the galaxy, and the bottles are chunks of ancient worlds. Now, let's talk about why Oumuamua in particular sparked so much controversy. Normally, when a comet accelerates, we can see the gas and dust jets responsible for that push. But Oumuamua didn't have that. Some scientists suggested it could have been venting pure hydrogen, which would be invisible to our telescopes. But that theory requires conditions so rare, it seems almost impossible. Others speculated it might be made of a strange type of ice, solid nitrogen, or even solid hydrogen, blasted off the surface of a Pluto-like planet during a cosmic collision billions of years ago. But then there's the Avi Loeb hypothesis, the idea that it could have been a light sail. Imagine a thin sheet, maybe only a fraction of a millimeter thick, catching the faint pressure of starlight to glide through space like a cosmic yacht. If that sounds like science fiction, consider this. Here on Earth, we've already tested something similar. The Japanese Ikaros mission and NASA's light sail both proved that solar sailing is real. Could an alien civilization, thousands or millions of years more advanced than us, have built such a probe? And if so, was Oumuamua a functioning spacecraft or just debris, an ancient relic of a long-dead civilization, drifting endlessly between the stars? These are the questions that keep scientists up at night. But here's where things get even more exciting. What comes next? Right now, new sky surveys like Vera Rubin Observatory's LSSD in Chile are preparing to scan the night sky like never before, detecting thousands of faint objects every single night. Once it goes fully operational, we might find interstellar visitors on a regular basis, maybe even dozens a year. And when that happens, we'll have opportunities we never had before. We can plan missions to intercept them. Think about that. Launching a spacecraft to chase an object from another star system, to study it up close, to sample its surface, maybe even bring a piece back to Earth. In fact, the European Space Agency and NASA have already discussed concepts like Comet Interceptor, a mission designed to wait in space for the next Oumuamua-like visitor and then pounce. It's like setting an interstellar trap, patiently waiting for a messenger from another world, and then chasing it down at incredible speeds. Why is this so important? Because these objects are time capsules. They carry material from other solar systems, chemical fingerprints of planets that formed under completely different conditions than ours. Imagine holding a rock in your hand that formed around another star billions of years ago. It's like archaeology, but on a galactic scale. These objects could tell us whether the building blocks of life, the amino acids, the complex molecules, are common in the galaxy. They might even show us chemistry we've never seen before. And if we ever find one that's artificial, well, that would change everything. Not just science, but human history. Now, let's zoom out and think about the big picture. Why are these visitors so rare to spot? It's because space is unimaginably vast. The sun's gravitational influence extends maybe 2 light years in every direction. That's the edge of the Oort cloud. But beyond that, it's empty, cold, and dark for light years until you hit the next star. For an object like Oumuamua to cross our solar system is like tossing a pebble across an ocean and having it land in a teacup. And yet here it is. What are the odds that it happened right now, while humans have telescopes? Could it just be luck? Or does it hint at something deeper, something about the dynamics of the galaxy we're only beginning to understand? And then there's the question nobody can resist. What if one of these objects really is a probe? If an alien civilization wanted to explore the galaxy, they might not send massive starships. Instead, they could send tiny, lightweight probes that drift through interstellar space for millions of years, powered by starlight or using gravitational slingshots. Such probes could carry vast libraries of knowledge, even self-replicating nanomachines capable of building new probes when they find raw material. If Oumuamua was one of those, did it notice us? Was it silent the whole time? Or did it send a signal home as it passed by? We have no evidence for that, of course, but the idea is tantalizing. And here's something to think about. Oumuamua entered our solar system from above the ecliptic plane, the flat disk where most planets orbit, almost as if it was coming from a higher vantage point. Pure coincidence? Probably. But when you deal with something this mysterious, coincidences tend to fuel speculation. Now let's turn back to Atlas, our new visitor. Unlike Oumuamua, Atlas is big, active, and bright, giving us a chance to study it in detail. Scientists will analyze its coma, its spectrum, its chemistry to see what it's made of. Does it resemble the comets in our own solar system? Or is it fundamentally different? If its isotopes, hydrogen, oxygen, carbon, have different ratios than what we see here, that would be groundbreaking. It would mean that planetary systems across the galaxy follow different chemical paths, producing different kinds of worlds. And that brings us to the ultimate question. Is life common out there? If these building blocks are everywhere, the odds go way up. And if life is common, then intelligent life might be, too. The next decade will be a golden era for these discoveries. With telescopes like the James Webb Space Telescope already revolutionizing astronomy, and new observatories coming online, we are entering an age when interstellar objects might go from rare curiosities to routine finds. And who knows, maybe one day an object will come not silently drifting but broadcasting a signal that says, you are not alone. Until then, every time we spot one of these cosmic messengers, we're reminded of just how small we are and how big the universe truly is. So as Atlas glides in from the dark, as astronomers scramble to learn every detail before it's gone forever, one question lingers. How many more out there? And what secrets do they hold? The answer could change everything we know, not just about the cosmos, but about ourselves. But the story of these interstellar messengers is only beginning, and it leads us into questions bigger than anything we've faced in planetary science. Before 2017, the idea that we would detect an object from another star system during our lifetime felt like science fiction. The universe is vast, and the chances of one of these cosmic wanderers crossing our tiny observational window seemed impossibly small. Yet here we are, 3 confirmed interstellar visitors in less than a decade. Oumuamua, Borisov, and now Atlas. What does that tell us? It means the galaxy could be teeming with such objects, trillions of fragments of ancient worlds drifting through interstellar space, each carrying clues about the environments where they were born. Some may be pieces of rocky planets shattered in violent collisions. Others could be remnants of frozen ocean worlds hurled out during the chaotic birth of alien solar systems. Every one of them is a messenger from a place we can only imagine. And that's what makes Atlas so important. Unlike Oumuamua, which slipped away almost as soon as we noticed it, Atlas gives us time, months of observation, close enough for detailed studies. Astronomers will use every instrument they have, from ground-based observatories to space telescopes like James Webb, to measure its composition, its gases, its isotopes. If its chemical fingerprint is different from anything in our solar system, that would be a discovery of staggering importance. It would mean that planetary systems across the galaxy follow different chemical recipes, different ways of building planets, moons, and maybe even life. Imagine what that means for our understanding of how common habitable worlds might be. If Atlas shows us that water, organic molecules, or other building blocks of life are abundant even beyond our solar system, then the odds of life existing elsewhere shoot up dramatically. But the implications go even further. Scientists are already dreaming of the next step, not just observing these objects from afar, but visiting them. The European Space Agency's upcoming Comet Interceptor mission is designed to wait in space until an object like this appears, then launch a rapid interception. NASA has similar ideas on the drawing board, including concept for spacecraft that could use solar electric propulsion or gravitational assist to chase down an interstellar visitor. Picture this: a probe racing across the solar system, catching up to a fragment of another star system, snapping photos, scanning its surface, maybe even collecting sample. If we could bring back a piece of an interstellar object, material that formed around a distant sun billions of years ago, it would be like holding a piece of another world in our hands. That's not just science, that's history being made. And of course, hovering over all of this is the most tantalizing question of all. Could one of these objects ever turn out to be artificial? Avi Loeb's controversial theory that Oumuamua might have been a light sail sparked endless debate. Most scientists disagree, but they can't prove him wrong. And if Oumuamua wasn't artificial, could the next one be? If an advanced civilization wanted to explore the galaxy, they wouldn't need giant starships. They could send millions of tiny probes, drifting for eons, powered by starlight or stored energy. Some might fail, some might survive for billions of years. We might already have passed a few without knowing it. It sounds like science fiction, but so did black holes once. The only way to know for sure is to keep watching, and to be ready when the next messenger appears. Because the more we look, the more we realize the galaxy is not empty. It's alive with movement, with stories waiting to be discovered. And these interstellar visitors, they're not just rocks. They're postcards from across the cosmos. Messages written in ice and stone, telling us that our solar system is just one tiny chapter in an endless galactic epic. The question now isn't whether we'll find another. It's how soon, and what secrets it will bring from the dark between the stars.